Metallurgy. It is interesting to know that our Earth was born about 4.5 billion years ago. Various formative processes have been taking place in the core of the Earth and its surroundings since creation till today, which has resulted in the formation of various substances like ores, solids, liquids and gases, etc. So in this chapter, we are going to learn some interesting facts about metals, non-metals and metallurgy. Substances around us. Everything physical that we see around us is made up of matter. What is a matter? The term matter describes all the physical substances around us which has a certain mass and occupy space. They could be either in solid, liquid or gas form. For example, table, pen, water, blackboard, etc. Every matter is subdivided as a substance and mixture. Substances that we come across daily are further classified as 1. Elements. 2. Compounds. Elements are fundamental substances which cannot be further separated into simpler form, whereas compounds are substances which are formed by 2 or 3 elements in fixed proportion and can be separated into simple forms. Elements and its classification. Element can be 1. Metals, 2. Non-metals or 3. Metalloids, depending upon their physical and chemical properties. So let us start now and learn more details about this metal and non-metals. Physical properties of metals, non-metals and metalloids. After having understood the classification of substances and elements, let us now explore these elements in detail and study their properties. Properties are of two types. 1. Physical properties. Those properties which are externally visible to us. 2. Chemical properties. Those properties which are internally present and visible only on chemically reacting it with other substance. Let us learn the physical properties first. Physical properties of metals. 1. Metals exist mainly in solid state. Exception: mercury and gallium exist in liquid state at room temperature. 2. Metals possess luster. The metallic luster goes on decreasing due to exposure to atmospheric oxygen and moisture and also in presence of some reactive gases. 3. Metals have the properties namely ductility and malleability. 4. All metals are good conductors of heat and electricity. 5. All metals are hard. However, the alkali metals from group 1 such as lithium, sodium and potassium are exceptions. These metals can be cut with knife as they are very soft. 6. Metals have high melting and boiling points. For example, tungsten metal has the highest melting point 3422 degrees Celsius. On the contrary, the melting and boiling points of the metals such as sodium, potassium, mercury, gallium are very low. 7. A sound is produced when certain metals are struck. This is called sonority. These metals are known as sonorous metals. Physical properties of non-metals. 1. Non-metals are in solid, liquid and gaseous state. 2. Non-metals do not possess luster, but iodine is the exception as its crystals are shiny. 3. Non-metals are not hard. Diamond, which is an allotrope of carbon, is the exception. Diamond is the hardest natural substance. 4. Non-metals have low melting and boiling points. 5. Non-metals are bad conductors of electricity and heat. Graphite, an allotrope of carbon, is an exception as it is a good conductor of electricity. 6. Non-metals do not have the properties, namely ductility and malleability. Reactivity of metals. Before we move to learn the chemical properties of metals and non-metals, let us get a brief idea about the reactivity of metals with salts of different metals and non-metals. Metals are highly reactive. As they lose electrons easily and become positively charged ions, they are also called as electropositive elements. The reactivity of all metals is not the same. Example: if a metal A displaces another metal B from the solution of its salt, then it means that the metal A is more reactive than the metal B. The arrangement of metals in the increasing or decreasing order of reactivity is called the reactivity series of metals. Metals are divided into the following groups according to their reactivity. 1. Highly reactive metals. 2. Moderately reactive metals. 3. Less reactive metals. For example, in the example shown, the metal iron displaces copper from copper sulfate, which means that iron is more reactive than copper. The easiest way to remember the reactivity series of metal is shown here in picture. As you go up the series, the reactivity increases. Chemical properties of metals and non-metals. Chemical properties of metals. A. Reaction of metals with oxygen. Metals combine with oxygen on heating in air and metal oxides are formed. For example, sodium metal combines with oxygen in the air even at room temperature and forms sodium oxide. B. Reaction of metals with water. Sodium and potassium metal react rapidly and vigorously with water and liberates hydrogen gas. Calcium reacts with water slowly and less vigorously. The hydrogen gas released in this reaction collects on the surface of the metal in the form of bubbles, and the metal floats on water. The metals aluminium, iron and zinc do not react with cold or hot water, but they react with steam to form their oxides. Hydrogen gas is released in this reaction. C. Reaction of metals with dilute acids, HCl. When samples of aluminium, magnesium, iron or zinc are treated with dilute sulfuric or hydrochloric acid, sulfate or chloride salts of metals are formed. Hydrogen gas is liberated in this reaction. The reactivity of these metals can be indicated by the following sequence. Mg is greater than Al is greater than Zn is greater than Fe. Magnesium, when reacts with dilute sulfuric acid, gives magnesium chloride and hydrogen gas is released. Aluminium, when reacts with dilute sulfuric acid, gives aluminum chloride and hydrogen gas is released. D. Reaction of metals with nitric acid. Nitrate salts of metals are formed on reaction of metals with nitric acid. Various oxides of nitrogen, N2O, NO, NO2 are also formed. For example, copper, when reacts with nitric acid, gives nitrate salt of metal and nitrogen dioxide and water is released. E. Reaction of metals with salts of other metals. When a metal reacts with the salts of other metals, then the more reactive metal displaces the less reactive one. In the example shown, the metal iron displaces copper from copper sulfate, which means that iron is more reactive than copper. Reaction of metals with non-metals. When metals react with non-metals, then ionic compounds are formed. For example, the ionic compound sodium chloride is formed as sodium metal, gives away one electron, while the non-metal chlorine takes up one electron. Chemical properties of non-metals. Non-metals are a collection of elements having less similarity in physical and chemical properties. Non-metals are also called electronegative elements, as they form negatively charged ions by accepting electron. A. Reaction of non-metals with oxygen. Non-metals combine with oxygen to form acidic oxides or neutral oxides. For example, when carbon combines with oxygen, it forms carbon dioxide. B. Reaction of non-metals with water. Among the non-metals, only halogens react with water to form hypohalides. For example, when chlorine reacts with water, it forms hypochlorite. C. Reaction of non-metals with dilute acids. Among the non-metals, only halogens react with dilute acids to form hydrogen halide. For example, when chlorine reacts with dilute hydrobromic acid, it forms hydrogen chloride. D. Reaction of non-metals with hydrogen. Non-metals react with hydrogen under certain conditions of temperature, pressure, catalyst, etc. to form a particular gas. For example, when sulfur reacts with hydrogen, it forms hydrogen sulfide gas. Ionic compounds and its properties. What are ionic compounds? The compounds formed from two units, namely cation and anion, are called ionic compounds. The cation and anion being oppositely charged, there is an electrostatic force of attraction between them. The electrostatic force of attraction between cation and anion is called as the ionic bond. The arrangement of ions is different in different ionic compounds, and therefore the shapes of their crystals are different. Two of the important factors responsible for a certain crystal structure are as follows. 1. Size of the positively and negatively charged ions. 2. Magnitude of the electrical charge on the ions. General properties of ionic compounds. 1. They are crystalline in nature. 2. They are electrically neutral. 3. Ionic compounds are brittle and can be broken into pieces. 4. They have high melting and boiling point. 5. They are soluble in water. They can conduct electricity only in fused or molten state and not in solid state. Metallurgy. What is metallurgy? The science and technology regarding the extraction of metals from ores and their purification for the use is called metallurgy. Metals can be extracted from their ores by means of various methods of separation. The process of extraction of metal in pure state from the ores is also a part of metallurgy. Meaning of metallurgy. Ores are taken out from the mines. The gangue is usually separated from the ore by various methods. The ores are carried out to the place where metals are produced. Their metals are extracted in pure form. Then metals are further purified by different methods of purification. This entire process is called metallurgy. Occurrence of metals. The metals which are found free in the nature are generally found in different forms. Let us understand those forms. 1. Minerals. The compounds of metals that occur in nature along with the impurities are called minerals. 2. Ores. The minerals from which the metal can be separated economically are called ores. 3. Gangue. Ores contain many types of impurities such as soil, sand and rocky substances along with a metal compound. These impurities are called gangue. Basic principles of metallurgy. Pure metals can be obtained from the ores by following stages. 1. Concentration of ores. A. Separation by gravitation. B. Magnetic separation method. C. Froth flotation method. D. Leaching. 2. Extraction of metals. A. Extraction of reactive metals, aluminium. B. Extraction of moderately reactive metals, iron, zinc, etc. C. Extraction of less reactive metal, copper, silver, gold, etc. 3. Refining of metal. Stage 1. Concentration of ores. The process of separating gangue from the ores is called concentration of ores. Some general methods for the concentration of ores are as follows. A. Separation based on gravitation. 1. Wilfley table method. In this method of separation, the Wilfley table is made by fixing narrow and thin wooden rifles on inclined surface. The table is kept vibrating continuously. Powdered ore obtained from lumps of the ore using ball mill is poured on the table and the stream of water is also released from the upper side. As a result, the lighter gangue particles are carried away along with the flowing water, while the heavier particles, in which proportion of minerals is more and proportion of gangue is less, are blocked by the wooden rifle and get collected on the slits between them. 2. Hydraulic separation method. The hydraulic separation method is based on the working of a mill. Steps. Finely ground ore is released in the tank. A forceful jet of water is introduced in the tank from the lower side. Gangue particles are lighter and therefore they flow out along with the water jet from the outlet on the upper side of the tank and get collected separately. At the same time, the heavy particles of the ore are collected at the bottom from the lower side of the tank. In short, this method is based on the law of gravitation, wherein particles of the same size are separated by their weight with the help of water. B. Magnetic separation method. In this method, the magnetic and non-magnetic particle present in the ore are separated by electromagnetic machine. Steps. The powdered ore is poured on the conveyor belt near the non-magnetic roller. The non-magnetic particles in the ore are not attracted towards the magnetic roller. Therefore, they are carried further along the belt and fall in the collector vessel placed away from the magnetic roller. At the same time, the particles of the magnetic ingredients of the ore stick to the magnetic roller and therefore fall in the collector vessel near and below the magnetic roller. For example, cassiterite is a tin ore. It contains mainly the non-magnetic ingredient stannic oxide, SnO2, and the magnetic ingredient ferrous tungstate, FeWO4. These are separated by the electromagnetic method. C. Froth flotation method. The froth flotation method is based on the two opposite properties, hydrophilic, soluble in water, and hydrophobic, insoluble in water, of the particles. Steps. In this method, the finely ground ore is put into a big tank containing ample amount of water. Certain vegetable oil, such as pine oil, eucalyptus oil, is added in the water for the formation of froth. Pressurized air is blown through the water. There is an agitator rotating around its axis in the center of the flotation tank. Bubbles are formed due to the blown air. Due to agitation, a foam is formed from oil, water, and air bubbles together due to the agitating. This foam rises to the surface of water and floats. That is why this method is called froth flotation process. For example, this method is used for the concentration of zinc blende, ZNS. D. Leaching. Steps. In this method, the ore is soaked in a certain solution for a long time. The ore dissolves in that solution due to a specific chemical reaction. The gangue from the ore can be separated out as it does not dissolve. For example, the concentration of bauxite, the aluminum ore, is done by leaching method. Here, bauxite is soaked in aqueous NaOH or aqueous Na2CO3, which dissolves the main ingredient alumina in it. Stage 2. Extraction of metals. A. Extraction of reactive metals. Aluminum. The metals at the top of the reactivity series are highly reactive. For example, potassium, sodium, aluminum are reactive metals. We are now going to see how aluminum is obtained by electrolytic reduction of aluminum oxide in the ore bauxite. Extraction of aluminum. Details of aluminum. Symbol Al. Atomic number 13. Electronic configuration 283. Valency 3. Color silver white. Aluminum is extracted from its ore bauxite. Bauxite contains 30% to 70% of Al2O3 and remaining part is gangue. It is made up of sand, silica, iron oxide, etc. Steps. 1. Concentration of bauxite ore. Bauxite is the main ore of aluminum. Silica, SiO2, ferric oxide, Fe2O3, and titanium oxide, TiO2, are the impurities present in bauxite. Separation of these impurities is done by leaching process using either A. Byers method, B. Hall's method. In both these methods, finally, the concentrated alumina is obtained by calcination. A. Byers process. In the Byers process, the ore is first ground in a ball mill. Then it is leached by heating with concentrated solution of caustic soda, NaOH, at 140 to 150 degrees Celsius under high pressure for 2 to 8 hours in a digester. Aluminum oxide being amphoteric in nature, it reacts with aqueous solution of sodium hydroxide to sodium aluminate and water. This means that bauxite is leached by sodium hydroxide solution. The iron oxide in the gangue does not dissolve in aqueous sodium hydroxide. It is separated by filtration. However, silica in the gangue dissolves in aqueous sodium hydroxide to form water-soluble sodium silicate. Aqueous sodium aluminate is diluted by putting in water and is cooled to 50 degrees Celsius. This results in precipitation of aluminum hydroxide. B. Hall's process. In the Hall's process, the ore is powdered, then leached by heating with aqueous sodium carbonate in a digester to form water-soluble sodium aluminate. Then the insoluble impurities are filtered out. The filtrate is warmed and neutralized by passing carbon dioxide gas through it. This results in the precipitation of aluminum hydroxide. The precipitate of AlO3 obtained in both Byers and Hall's processes is filtered, washed, dried and then calcined by heating at 1000 degrees Celsius to obtain alumina. 2. Electrolytic reduction of alumina. The alumina obtained from step 1 is electrolyzed in a steel tank. Melting point is more than 2000 degrees Celsius. The tank has a graphite lining which acts as cathode, and many graphite rods dipped in the molten electrolyte acts as anode. Cryolite and fluorspar are added to lower melting point to 1000 degrees Celsius. Aluminum gets deposited on the cathode and the molten aluminum gets deposited at the bottom of the tank. Oxygen gas is liberated at the anode. B. Extraction of moderately reactive metals, iron, zinc, etc. The metals in the middle of the reactivity series such as iron, zinc, lead, copper are moderately reactive. They occur in the form of their sulfite salts or carbonate. The oxides are easily extracted from these metal sulfide or carbonate ores by the process of roasting and calcination, and then they are reduced to get pure metal. 1. Roasting. When the sulfide ores are strongly heated in air to transform them into oxides, this process is called roasting. 2. Calcination. When carbonate ores are strongly heated in a limited supply of air to transform them into oxides, this process is called calcination. The zinc oxide ZnO so obtained is reduced to zinc by using suitable reductant such as carbon. Apart from carbon, reactive metals such as sodium, calcium, aluminum are also used as reducing agent for the reduction of metal oxide to obtain the metal. A. Extraction of less reactive metal, copper, silver, gold, etc. The metals at the bottom of the reactivity series of metals are less reactive. That is why they are found in free state in nature. For example, gold, silver, platinum. The reserves of copper in free state are very few. Presently, copper is found mainly in the form of Cu2s. Copper is obtained from Cu2s or just by heating in air. Stage 3. Refining of metals. Metals obtained by the various reduction processes are not very pure. They contain impurities. The impurities need to be separated to obtain pure metal. Electrolysis method is used to obtain pure metals from impure metals. The picture shows the electrolytic refining of metallic copper. Corrosion of metals. The common phenomenon that we come across daily and experience it frequently at our home, for example, like the change in the color and appearance of the metals like iron rod used in construction, silver chain, copper vessel, etc. This change is called as rusting. Rusting leads to corrosion of metals. What is rusting? The corrosion of iron is called as rusting. Process of rusting. Iron reacts with moist air and deposits a reddish substance, Fe2O3H2O. This is called as rust. Carbon dioxide in moist air reacts with surface of copper vessel. Copper loses its luster due to formation of greenish layer of copper carbonate, CuCO3, on its surface. This is called patination of copper. On exposure to air, silver articles turn blackish after some time. This is because of the layer of silver sulfide, Ag2S, formed by the reaction of silver with hydrogen sulfide in air. By oxidation of aluminum, a thin layer of aluminum oxide forms on it. Methods to prevent corrosion. 1. Galvanizing. In this method, a thin layer of zinc is applied to prevent corrosion of iron or steel. For example, shining iron nails, pins, etc. In this method, corrosion of zinc occurs first because zinc is more electropositive than iron. After a few rainy seasons, the zinc layer goes away and the inner iron gets exposed. Then iron starts rusting. Tinning. In this method, a layer of molten tin is deposited on metals called as kalai. For example, a greenish layer forms on the surface of a copper or brass vessel. This greenish layer is poisonous. If buttermilk or curry is placed in such a vessel, it gets spoiled. Tinning is done to prevent all such damages. 2. Anodization. In this method, metals like copper, aluminum are coated with a thin and strong layer of their oxides by means of electrolysis. For this, the copper or aluminum article is used as anode. For example, when aluminum is anodized, the thin layer of aluminum oxide is formed. It obstructs the contact of the aluminum with oxygen and water. This prevents further oxidation. This protection can be further increased by making the oxide layer thicker during the anodization. 3. Electroplating. In this method, a less reactive metal is coated on a more reactive metal by electrolysis. For example, silver-plated spoons, gold-plated ornaments are the examples of electroplating. 4. Alloying. The homogeneous mixture formed by mixing a metal with other metals or non-metals in certain proportion is called an alloy. For example, 1. Bronze is an alloy formed from 90% copper and 10% tin. Bronze statues do not get affected by sun and rain. 2. Stainless steel does not get stains with air or water and also does not rust. It is an alloy made from 74% iron, 18% chromium and 8% carbon.